Module that implements a NOT gate. This circuit is similar to wire, but with a slight difference. When making the connection from the wire into the wire out, we're going to implement an inverter or NOT gate instead of a plain wire. Use an assign statement. The assign statement will continuously drive the inverse of in onto wire out. Expected solution length, around one line. Module that implements an AND gate. This circuit now has three wires, A, B, and out. Wires A and B already have values driven onto them by the input ports, but wire out currently is not driven by anything. Write an assign statement that drives out with the AND of signals A and B. Note that this circuit is very similar to the NOT gate, just with one more input. If it sounds different, it's because I've started describing signals as being driven has a known value determined by something attached to it, or not driven by something. Input wires are driven by something outside the module. Assign statements will drive a logic level onto a wire. As you might expect, a wire cannot have more than one driver. What is its logic level if there is? And a wire that has no drivers will have an undefined value, often treated as zero when synthesizing hardware. Verilog has separate bitwise and logical and operators like C. Since we're working with a 1-bit here, it doesn't matter which we choose. These are timing diagrams from some of the test cases we used. They may help you debug your circuit. The diagrams show inputs to the circuit, outputs from your circuit, and the expected reference outputs. The mismatch trace shows which cycles your outputs don't match the reference outputs. 0 equals correct, 1 equals incorrect. Create a module that implements a NOR gate. A NOR gate is an OR gate with its output inverted. A NOR function needs two operators when written in Verilog. An assign statement drives a wire, or net, as it's more formally called, with a value. This value can be as complex a function as you want, as long as it's a combinational, i.e., memoryless, with no hidden state, function. An assign statement is a continuous assignment because the output is recomputed whenever any of its inputs change, forever, much like a simple logic gate. Verilog has separate bitwise OR and logical OR operators like C. Since we're working with a 1-bit here, it doesn't matter which we choose. Create a module that implements an XNOR gate. The bitwise XOR operator is caret. There is no logical XOR operator. The same way, but for now, we'll start with a signal of type wire. Declaring wires. The circuits so far have been simple enough that the outputs are simple functions of the inputs. As circuits become more complex, you will need wires to connect internal components together. When you need to use a wire, you should declare it in the body of the module, somewhere before it is first used. In the future, you'll encounter more types of signals and variables that are also declared the same way, but for now, we'll start with a signal of type wire. Example: module top underscore module, impedance, // declare an input wire named in output. In the above module, there are 3 wires, in, out, and not underscore in, 2 of which are already declared as part of the module's input and output ports. This is why you didn't need to declare any wires in the earlier exercises. The wire not underscore in needs to be declared inside the module. It is not visible from outside the module. Then, 2 NOT gates are created using 2 assign statements. Note that it doesn't matter which of the NOT gates you create first. You still end up with the same circuit. Circuit. Practice. Implement the following circuit. Create 2 intermediate wires, named anything you want, to connect the and or gates together. Note that the wire that feeds the NOT gate is really wire out, so you do not necessarily need to declare a 3rd wire here. Notice how wires are driven by exactly one source, output of a gate, but can feed multiple inputs. If you're following the circuit structure in the diagram, you should end up with 4 assign statements, as there are 4 signals that need a value assigned. Yes, it is possible to create a circuit with the same functionality without the intermediate wires.